Okay, here we are, lesson 1. I'm Mr. Jackson.
I'm Miss Hughes.
And we are going to present you the first little bit of teaching in data analysis, but really looking at collecting and presenting data. So this is our first lesson in statistics. And we need to start somewhere, so usually a good place to begin is with some definitions, because statistics requires patience and it requires precision. So if we're going to do it, let's do it right and take a look at some statistical language. So first of all, what is stats? Statistics is gathering, organizing, analyzing, and presenting numerical information. You can't have statistics without any of these parts, and it's really, really important that they're all included. Gathering data. Let's take a look at that just briefly by examining, okay, what is data? So raw data is information that we've gathered before any organizing, analyzing, or presenting has been done. It's called uncompressed because nothing's done to it. There's no conversions, there's no percents, it's just as it is. And we should note at this point that data is actually a plural for the singular form of datum, which is a fact or a piece of information. So the datum is the singular, data is the plural.
And if you don't want to feel too fancy, you can say data point.
Yes,
if you want to talk about one value, that way you're not, and the datum suggests.
Yes, and because datum sounds weird. Yeah. And so
so we're collecting things and we want to discuss the things we're collecting, and we're going to call them variables, especially when we start collecting more than one of them and seeing if one has any effect on the other. We'll define a variable as a quantity that can have any of a set of values. So you may recognize something like x is an element of the real numbers. That's the set of real numbers. We may have other sets, but a quantity having a set, any of a set of values, that's what we're going to define as our variable. Now we can break our variable definitions up into two parts. We can talk about continuous variables and discrete variables. A continuous variable is one that can have an infinite number of possible values along a range. And I like to think of continuous variables as ones where you can measure the data to greater and greater specificity if you have more and more sensitive measuring tools. Like if you're measuring time or you're measuring volume, you can go to more and more decimal places if you have more specific and sensitive tools. And so a continuous variable is one where you really could, even in between two finite values, have an infinite number of possible values between them. So that's where I like to sort of have you thinking of continuous on those terms, whereas discrete, often they're integers. You either have it or you don't. You either made the phone call or you didn't make the phone call. So you wouldn't say you made 3.257 phone calls today.
Yep.
So you're looking mostly at data that is discrete, that you can count. I made 1 or 2 or 3 of them. And another class of this would be categorical data, where you would have something like color or shape.
Yes.
Where you have so many of these and so many of those, where they're not numbers, but they're categories or classes. Once we have the data, it's often helpful to group it. If it is only a few discrete values or it's some categorical data like hair color or something like that, then you may not want to put it into intervals or group. You may want to leave it ungrouped and just look at it piece by piece. But if you have a great number of continuous variables or a great number of discrete variables, then we're going to want to create intervals so that we can see better how many we have of each type. So we'll define the interval as a set of all numbers that are between two given values. So at this point, if you could highlight or underline the word between, the implication is that the two values that are the endpoints, the left endpoint and the right endpoint of the interval, are not included. So if I wanted to talk about the numbers 5, 6, and 7, and I wanted to put them in an interval, then I would set the interval 4.5 to 7.5, because then the set of all numbers between 4.5 and 7.5 are the numbers 5, 6, and 7. So note that, like a bookshelf in books, that the endpoints of your intervals are like bookends for your books. Okay, so that you have endpoints that aren't books, they're like bookends. That's how I like to think of it anyway. Once you've got the raw data, the way to figure out how big your intervals are, the interval width, the first step is often just finding the range, and the range tells you some good things about the data anyway, so we often look to that first. The range is just the difference between the highest and the lowest values in your data set. If you don't have a spreadsheet or some kind of software, then often you're picking and choosing and just trying to, by inspection, find your maximum minimum values, and then subtract them to find the difference, and that's your range.
Okay, so we've kind of flown through a whole bunch of definitions here, and don't worry if you don't fully understand. We're going to be using all these words and all these terms in the coming pages of this lesson. So let's look at bar graphs and histograms. Bar graphs show discrete data. Histograms show continuous data. So let's talk about bar graphs first. They are used to display discrete variables. So any categories or any set of individual discrete data, we're going to use a bar graph. There's a space in between each bar, and as you can see in this diagram, we've got red, blonde, brown, black, purple, and green as hair color on the x-axis, and on the y-axis we have frequency. The length of each bar, or the height in this case of each bar, is proportional to the frequency or the quantity of each variable. So if we look at this, we can say there were 5 blonde-haired people in this sample that we collected data about. There were 3 people with red hair, 10 people with brown hair, so on and so forth.
Histogram, on the other hand, we're going to use to display continuous variables. So notice that you generally create a bar graph and then you set the gap width or the width between the bars to be 0. So when you create a gap width of 0, you push the bars together, then you're showing the viewer visually that this data is continuous, that it's not discrete categories, that you can blend one into the next, and that with a number of decimal places and sensitive measuring tools, you can actually create an infinite number of values.
Yep.
Notice also frequency is the same on the y-axis. We'll talk about, there are a few different things you can put there like relative frequency or cumulative frequency, but generally we're doing a proportion of the total sample or population is on the y-axis, and then on the x-axis you can see we have intervals from 0 to 5, 5 to 10, 10 to 15, and that the left and right endpoints of those intervals are representative of the left and right endpoint of those bars.
Yes.
Okay. This will look a little bit different when we start to do polygons. We'll show you how that looks. So it's continuous variables. The same principle applies. The height or the length of each bar is proportional to the frequency or quantity of each variable that you see. Click again for me, Mr. Jackson. And yeah, just as we already mentioned, it can be in several forms. This one is a frequency histogram. We may also look at a relative frequency and a cumulative frequency on the next page.
And that's what we're going to now. So basically a different type of graph. We've got bar graphs and histograms, which is primarily what we're going to use. But we could also introduce something that's called a polygon. And so instead of giving a representation of the data with bars, we can give a representation of the data with points and lines connecting those points. So here, instead of giving a bar that has an interval associated with it, we take the midpoint of a given interval, and where we would have the height of the bar, say perhaps at this point right here, our bar height would go up to 2, because that would be the frequency, we put a dot at the midpoint.
So these middle values, the reason we choose a midpoint is because these are points rather than intervals now, and that the midpoints are connected. And again, because lines are continuous, the polygons are only used to display continuous data. So if you could make a histogram, then you can also make a polygon. But if you've made a bar graph for your discrete data, you generally are not going to want to represent that as a polygon as well. Okay. Now the relative frequency histogram, you'll notice looks very similar. If you hold it side by side, it looks very similar. The heights are the same, the intervals are the same on the x-axis, but what you notice if you look at the y-axis is that instead of having 0, 2, 4, 6, 8, 10, 12, we have 0, 0.05, 0.10, and so on, so that we've actually created proportions, and in this case, as a proportion of 1, but we could also change those to percents. So this is generally a fraction of the total. What it does for a viewer is it simplifies things so that you can see at what fraction of one whole is represented by the height of each of these bars. But what it also does is it takes away from the viewer the ability to see how many items were in your sample. We knew that 2 were at this height and 5 were at this height and so on, but taking away those absolute values and making it a relative frequency has added an element of ease for viewing, but has also removed a little bit of information from the viewer.
Yeah, so if one wanted to be deceptive and use a small sample, this is one way that we could do it. If we wanted to, try and give some convincing data on something that's quite shocking, and we could use a small sample size to do that, we could remove that information and just give a relative frequency histogram. Very similar to the polygon up here is a cumulative frequency polygon, but it tells us about something a little bit different. A cumulative frequency is a running total of the frequency. And so this graph, and we'll talk about how to do this later, but this graph is really good at telling us the amount or the frequency at or below a certain number. And so we can look at this data point and we can say, oh, well, if we're measuring travel time to school, we could say that in this class, 26 people in this sample have a travel time at or below 22.5 minutes. And that can be very, very helpful. It's also good at looking at rates of change. And if you're taking advanced functions, or if you've taken advanced functions, you'll know that the rate of change in this area of the graph is, of course, greater and in a different direction than the rate of change in this area of the graph. Here we have increasing quickly. Here we have increasing, but not quite as quickly. So what we want to do now is say, okay, let's take a look at an example. Because really, this stuff will start to present itself by actually doing it, and you'll get a good sense. So we're going to do this in a couple ways. We're going to do it by hand first, and then we're going to do it using Microsoft Excel in a couple moments. So first, let's examine by hand. Here is our data. These are daily high temperatures in July for Waterloo, Ontario. You'll notice July 1st, 2nd, 3rd, 4th, all the way to the 31st. And for every single day, we have a temperature that's listed there. We have 31 pieces of data. And so what we like to do now is we like to analyze a couple of questions.
So we want to know, in order to set up a table, in order to create some kind of visual representation, we need to know, is it going to be a histogram or is it going to be a bar graph? Should we make intervals and make a table, or should we just leave it as categorical? So we want to know, first of all, what do we think? Is temperature discrete or continuous? And because I could measure temperature to greater and greater specificity, and there probably are an infinite number of temperatures, we'll call it continuous, okay? Which means that we can use a histogram, and also if we want to, we can use a polygon, because both of those are useful for continuous variables.
That's right. So now we need to ask, should we group our data, or should we leave it ungrouped? And what do you think about that?
Well, I like grouping the data in this case, because we really could go either way, but in this case, because we have a significant number of variables, it would be easier to view them grouped rather than looking at this number, each one getting its own bar graph, each one getting its own value in the histogram. You would want to keep it ungrouped if you had classes or categories like we were talking about hair color.
Yes.
Or if you just had a few discrete values. Like if you only had 0 to 4, and it was 0, 1, 2, 3, 4, then each one of those would get its own bar. At that point, it would be discrete instead of continuous.
But here, if we didn't group it, that would mean that we'd have 31 distinct bars in our data set. And is that going to be helpful? And so this way, we could leave it ungrouped, but maybe that's not going to be as helpful as if we group it all together. So let's talk about grouping it. If we're going to group our data, we need to determine a range and a suitable interval size. So first, let's talk about range. We know that if we actually go back to the raw data, to the chart that we have in our note, we search through and we try and find the maximum temperature. And it happens to be 33 degrees on July 15th. We can also look then to try and find the minimum temperature, and we see that on the 24th, the temperature dipped to 18 degrees. The range is simply the highest data point minus the lowest data point, and here we get a value of 15.
So using that range of 15, we say, okay, well, lowest to highest, 18 to 33, we've got 15 units in between the lowest and the highest. So we want to create a moderate number of intervals. The question you're asking yourself is, what the heck is a moderate number of intervals? I'm glad you asked, and Mr. Jackson and I made you a nice little flow chart.
Yeah. Love flow charts.
Don't we just love that? So taking your raw data, we've already made the decision that it's numerical, and it's either continuous or a lot of discrete. Okay, that's our temperature, so we're on the right-hand side. We found the range by subtracting the lowest from the highest. We got our range is 15. And now our definition of moderate, here we're going to use 5 to 20 equal-sized intervals that will fit our range of data. So if we go to the very minimum number of intervals, 5, and we take our 15 divided by 5, then we create an interval width of 3 degrees. So that means that each interval would have 3 degrees in it. Because we don't always love to use the very minimum of 5.
Yeah, I was going to say 5 seems to be the absolute minimum. Let's go a little bit higher than that.
So why don't we make the interval width 2,
Yes.
And then we go up by 2s for each interval,
Yeah.
and then we tally how many are in each interval there.
And this process of going back and forth is something that you'll do with your data as well. You don't have to live by the rule that, it has to be either 5 or it has to be a width of this. You can say, looking at my data, I think an interval width of 2 would be appropriate. So 2 degrees is going to be in every single interval that I have.
Now, just going on that logic and without thinking any further about actually putting data into an interval, then you're thinking to yourself, okay, 18 to 20 is the first interval.
And then 20 to 22, and then 22 to 24. But hold on, there's a problem with that reasoning.
And that's on July 25th, we have a temperature of 20 degrees.
So where does that go? Does that go into the lower frequency interval, or does it go into the higher
Do we put it
interval?
in 18 to 20 or 20 to 22?
And so that kind of misconception is something that in statistics can't happen. That really is one of those things. When we talk about doing statistics in a precise way, it's not enough to say, okay, well, we're always going to put those ones in the higher category. Can't happen like that.
Yeah, we need to be clear. You can use interval notation if you've done that in advanced functions where you use the round brackets and the square brackets, but your textbook uses another method. And so we want to teach you that method so that this makes sense to you, and you can use either method when you get to university. What you can do is we can take that 18, that lowest data point, and the general method that we're going to use is we're going to add 1 decimal point of specificity. We're going to add a significant figure.
Yes, exactly.
So it'll be 18.0, and now we're going to back it off half a unit.
Yeah.
So that 17.5 will be the left endpoint of our first interval. It will definitely include the lowest value.
Yeah, because 17.5 to 19.5 definitely includes 18.
Yep. And it is an interval width of 2, which is what we wanted to
And this is an
determine.
interval width of 2. So instead of saying 18 to 20, which is really what we thought, okay, that would be our first interval, what we do is we back it off by 1 significant figure, half of a unit, and we say 17.5 to 19.5. And if you look at the data, there's nothing in this chart that could be 19.5. There's nothing in there that could be 17.5. There will be no question. Where does 18 fall? 18 falls in this bracket. Now we look at, okay, well, between these two, where does 20 fall?
Now we know for sure.
Now we know for sure it goes in the second interval.
And if you like analogies, then you can think, I know I mentioned it already, that these endpoints are like bookends, and the bookends are not books.
Exactly.
So you're putting them on, you're deciding which shelf to put the books on, which interval to put your tally in, and you need to make sure that the endpoints of the interval cannot be misinterpreted as being data points.
Yes, exactly. Now, the midpoint then is basically halfway in between the 2 endpoints of each interval.
It's like an average.
It's like an average, and that's the best way to think about this. So 17.5 plus 19.5 divided by 2 is 18.5. And of course, that's all the work that you need to do, because now from here on down, we just add 2 to the first midpoint, because 2 is our interval width, and we get all the midpoints. Why are we doing midpoints? Well, because we might want to do a cumulative frequency diagram later on, or cumulative polygon later on. Okay? So to do a tally, and that's kind of the next thing, we actually go back to our raw data. And now this is the time when we start taking that raw data and organizing it into its intervals. So this would be the second phase of statistics. Yep. We've gathered it, now we're going to organize it. So we're going to take this tally and we're going to say, all right, so in the first temperature, 27 degrees, that fits into the 5th category, this one right here, and I would place a tick here. The second, 25 degrees, fits into this category, and I would place, this category, and I would place a tick there. And so on and so forth, until what we've done is that we've created a tally, and we have recorded the number of days where the temperature was within this range.
So just to back up there, if the temperature was 25, then you notice that it doesn't fit into the first or second or third interval, but it does fit into the 4th interval because that goes from 23.5 to 25.5. So this is an extremely time-consuming way of tallying up the data that fits into each interval, because you go back to the raw data, decide where it fits, cross it off, move to the next datum, figure out where it fits, cross it off.
Yeah.
So if you did this by hand, we did this for you. But if you wanted
Yeah.
to really see what this was like, do this by hand
Yeah.
and see how time consuming
And
it
it
is.
takes a long time doing this stuff by hand. You have to be thinking at this point, there's got to be a better way to do this. And there is. So now we can find our frequency. We've got our tally. The frequency is simply just the number in the tally added up. So here we have 2. The next one we have 2. The next one we have 2. Here we have 5. And so on and so forth all the way down. So the frequency is really just the tally. And from here, we can now create our cumulative frequency and our relative frequency. Again, one thing to check is to make sure once you've calculated your frequencies, add them all up.
Tally them up.
Because you better get a total of 31. We had 31 data points to begin with. We better have 31 as a total of our frequency.
If not, then you missed one.
If not, then you've missed one. You got to go back and do it again. Another reason why this is time consuming. Cumulative frequency then is a running total. So to begin our running total, obviously, we start with 2. And we put it right here. And then to that, we add the next. And to that, we add the next. And to that, we add the next. So what we get is we start with 2. We add 2 to it to get 4. We now have 4. We add 2 to it to get 6. We have 6. We add 5 to it to get 11. And we keep this running total going. We'll show you why it's important later. But for right now, that's how we do a cumulative frequency.
And there's a built-in check because it's possible that you missed a data point. It's possible that you've created intervals that don't include your highest number or something. But that cumulative frequency, the very last value, it should say that there are 31 pieces of data at or below 33.5 degrees.
Mm-hmm.
So all 31 pieces of data should be there, and that last number should be 31.
Yep, exactly. So now the relative frequency is really, this can be expressed in terms of a fraction, it can be expressed in terms of a decimal or a percent. But here what we do is we take the frequency in this interval and we divide it by the total. The frequency in this interval, divide it by the total. And so on and so forth all the way down, and we've explicitly written this as a fraction so that you can see, oh, 2 over 31, 2 over 31, 2 over 31, 5 over 31, 6 over 31, and so on and so forth, so that you can explicitly see, yes, this is a fraction of the total. We could also express this, as we said, decimal or percent. So let's use this to now answer a few questions. So let's say, how many days was the temperature, the maximum temperature, 25 degrees or less?
Or less.
So take a look at your completed chart. And on that completed chart, we can say, okay, find, this is really asking about cumulative frequency.
It really is. So you can go 2 ways. If you go to the cumulative frequency column and then go left and look to see the endpoint, if there's an endpoint that's 25.5, that will cover 25 degrees or less, then that means that the cumulative frequency for the interval that has 25.5 as the endpoint, that'll tell you how many pieces of data were at or below 25, because cumulative frequency is a running total. The other thing you could do is you could say, okay, interval, I see that you have 5 in you, okay, just for the frequency, and then say the previous interval had 2, the previous interval had 2, and then the other interval, the very first interval also had 2. So the sum of all the different values for those 4 intervals is 11. And so you can sort of do that cumulative frequency by hand, but this is a great opportunity to use the cumulative frequency column to figure out a value pretty quickly.
So we've actually got 11 days where the maximum temperature was 25 degrees or less. Let's flip it around. Let's say what proportion of days was the temperature greater than or equal to 30. So again, looking at the chart, we say, okay, 29.5 and above. And how many of those days was it 29 and above, 29.5 and above?
We can add those two.
And so we add those two together and we say 5 plus 4. So that's the number of days. But this doesn't ask for the number of days. It asks for the proportion of days. So really it's asking for a relative frequency. So we divide by the total number of days and we get this proportion, 9 of 31, where the temperature was greater than 30 degrees Celsius. So from here, the first part of the lesson's done. Now we want to use Excel.
I want to show you how to do this faster in Excel. I want to show you how to use formulas and show you how to use the autofill feature in Excel to save yourself time when typing up formulas.
Exactly. And so what we'll have at this point is, if you open the file that we gave you on the website,
You'll just have the raw data.
You'll have the raw data.
Just the column A.
Right? Just column A right here. And so what we've done, we've already done all the work thinking about our intervals and thinking about our midpoints. And that kind of thinking happens whether you're using Excel or whether you're doing it by hand. So we've already done that thinking, so we've simply put that into here. And now what we want to do is we want to say, oh my goodness, doing all the tallies, the frequencies, everything, there's got to be an easier way. And there is.
There is an easier way.
And so what we're going to do now is we're going to go over how do we do frequency, cumulative frequency, relative frequency with Excel.
Yeah, using Excel formulas. Now, if you recall when we did it by hand, the first thing we did was the tally and we translated them to a frequency, and then we just added the frequencies to create the running total of the cumulative frequency. We're going to use a feature in Excel called the Countif function, and what that means, though, is that we're actually going to find the cumulative frequency first. And the way that we're going to do that, Mr. Jackson, I just noticed, can you respell cumulative frequency? Now, we are testing your spelling in data class,
no,
but it is handy. We'll switch around the M and the U. There we go. Now it's cumulative frequency. And so we're going to hit equals.
All right, equals.
And we're going to type in Countif because we're going to ask Excel to start doing a count for us. We're going to open the brackets. And we're going to select where we want Excel to go to perform the count. So we need to select the range, and our range of data is just going to be from A2 all the way down to A32, and that includes all 31 pieces of our data. Okay. So we can close the bracket there because we've ended the range. So we're saying go here to A2 to A32 and count if it meets the following criteria. Okay. We're going to open up a quotation mark. We're going to type in less than. And here's what we're doing. Because it's cumulative, we want to know how many in that data range are less than 19.5. So that's the right end of our endpoint for that interval. We end the quote, end the bracket, hit enter.
And this should give us
2.
And it does.
And so, and we'll get Mr. Jackson to click back in. So notice we're saying go to A2 to A32, count how many of them are less than 19.5. If we wanted to use the autofill feature, then what that implies to Excel is that we're going to take every value and we're going to move it down to the next cell and down to the next cell. Mr. Jackson, can you just move it down 1? Okay, and then if he clicks into that second cell, notice that something has changed. Instead of A2 to A32, it has moved the data values down to A3 to A33. So we've actually lost...
I don't want that because I've lost this piece of data right here.
And each time we autofill down, we'll lose another piece of data.
So how do I fix that?
Let's go back into the first cell.
Okay, so I'll delete this because we don't want that.
We don't want that. Go back into the first cell. We're going to do something called absolute cell referencing. And just like absolute values, we're going to make sure that we keep this exact range and don't move it. We type in a $sign in front of the column, the A, and then a $sign in front of the number 2, and that is going to fix A2 as the first value in our range.
And so now I can slide down counting if, but it's not going to change my data range.
Not going to change that. Now we may also want to do $A, $32, and that will ensure that the right end or the lowest end of our range doesn't move either. Okay.
So when I press enter now, this should not change.
Should still be 2.
What I have, and it is. So now though, if I do this and I select here and I go all the way down because now I want to fill the whole thing. Oh, they all say 2. Now how come they all say 2?
They all say 2 because we have the same right end endpoint. Notice for the first interval, the right end endpoint was 19.5. We want to change that now because we're in the second interval. We want that to be 21.5.
Oh, yeah.
And because it's cumulative, we want to be saying how many are less than 21.5.
So this now should be 4.
Yes. And so this is where there's a little bit of work here. In just recognizing that you need to use absolute cell referencing with the $signs around your range, and that you need to change your criteria to represent the right endpoint of each interval. And what should happen, as Mr. Jackson's typing all these in, is that this is going to mimic what you had in your cumulative frequency column in the chart that you did by hand. And that we can predict that the very last value in the cumulative frequency should be 31, which is the number of days.
hope it is.
And let's hope it is. So once we've created the cumulative frequency, then we're going to use Excel formulas, and we're going to find frequency, relative frequency, and cumulative relative frequency if we'd like. And that will be very quick and very easy, especially if we set up the formula the way we want it and then just use the autofill function to autofill down.
And there it is, 31.
There's 31. So now we're going to go backwards. We're going to say, all right, the frequency, we click in there. I'm going to get Mr. Jackson to type in equals, and then just click on the cell E2. Just click on the cell, and hit enter.
Okay.
Now for the next one, I'm going to get him to press equals, then click on E3
all right.
minus E2.
Oh, so we're almost undoing the running total.
The running total. Now what you can do is you can take that second value that we've done, we can autofill down, and what it's going to do, we want it to move down each time for us.
Oh.
So we don't use the absolute cell referencing. And so if Mr. Jackson can click in a few, then you can see that we've taken E9, which is 31, minus E8, which is 27. So that means that there are 4 values in that interval. So if Mr. Jackson goes backwards, then we can still do the 2 plus 2 got you 4, and then 4 plus 2 got you 6, and 6 plus 5 got you 11. And we can check that. But just by typing in, and really the first frequency is the first cumulative frequency, so there's no real formula there. But I didn't just type in 2. I typed in equals and then clicked on the cell where the cumulative frequency was. That means that if I made one change in here, if I realized there was a mistake, the changes would cascade through the whole spreadsheet and would fix themselves for me.
Yeah, so that's really good later on, yeah.
Okay, and then if we go to relative frequency now, let's do a built-in check. Let's go to the bottom of the frequency column. Sorry, I'm jumping around. Let's do a sum and just make sure we do have 31. So we do equals, sum, open the bracket, select the range of data, close the bracket, hit enter. There are 31. So we do know that we've done our frequencies right. There should be 31, just like the cumulative frequency, just like the raw number of data points. So let's go to relative frequency. We'll hit equals, then let's click on the cell D2. Let's divide by, and at this point, if you want to click on D10, you can do that, but you need to just do an absolute cell reference there. Because we do want the autofill to fill down for us, we just don't want that cell to change. That way, if I somehow found another piece of data and added it in, then we could just reference that number 31 and we didn't type it in manually. Okay, so relative frequencies, these are, proportions relative to 1.
So these are all the percentages, okay. And then a cumulative relative frequency is, I would guess, would be the cumulative frequency, and then we're going to divide by the total. So it's a cumulative relative frequency. Am I right?
Yep. And we'll still do the absolute cell referencing, just so that nothing moves on us.
So by the end of a cumulative relative frequency, I better have, oh, sorry, why don't I just do this?
Autofill
I better
down.
have 1, right?
Yes.
Because 100%. I better have 100%, and there I do. Good.
Okay. So what you had a chance to see here, and we're going to try this in the next class, we'll do this together, but what you had a chance to see is how to use Excel to significantly reduce the time it takes you to do these frequency charts, but also builds in formulas so that you can make adjustments and changes to your data later that will cascade through and you won't have to change a lot of different things.
Okay. Now, we've done this. We'd like to create now a frequency histogram. And we'll leave it up to you to calculate the cumulative frequency polygon and so on and so forth. But for today, we're going to create a frequency histogram. And so to do that, first of all, you want to select the data that you're interested in graphing.
Frequency histogram, select the column of data under frequency. If you wanted to make a relative frequency histogram, then you'd select the column of data under relative frequency. So once you've selected that data, these are going to be the heights of your bars. But we need to now suggest that Excel go in and make us a bar graph that we're going to change the gap width to 0.
And depending on what format of Excel you have, whether or not you're using the Mac version of Excel like I am, or whether you're maybe using the newest Office version of Excel, maybe you're using a really old version of Excel, this is all going to be a little bit different.
But it'll be under charts.
But it'll be under charts wherever you go. And the kind of chart that we want is
Column.
a column bar.
If you want them to go, if
Yeah.
you want the columns in terms of height, then we choose column. If you wanted the bars sideways, we'd go with bar. Let's choose a column graph.
Yeah.
Okay, and we're just going to choose the first one, clustered column.
Yeah. Simplest of the simple.
Simplest of the simple.
And here it is. And so now what it's given us is it's given us this whole display, but this isn't really listed the way we want. Our frequency over here is right, but there's no title on our axes.
Yep.
Excuse me, there's no labels on our axes. This scale down here
Is not right.
is not right.
And these are bars.
These are bars. This is continuous data.
So we want the
So,
bars to be
we want the bars to be together. So there's a whole bunch of stuff that we need to fix in this. And so what we need to do is we need to say, all right, well, first of all, we need to fix basically what we're telling this down here.
Yep.
What we're telling this down here. And so we can say, all right, well, if we...
often we can right-click, depending on the version that we have in school, you can right-click on the data, and you can format. You can select data to choose. So instead of having 1, 2, 3, 4, 5, 6, 7.
So this is fine, but really, it's the x-axis labels that are not great. And so what we'd like to do is we'd like to actually have the intervals. So here we can change and we can select our intervals. And all of a sudden now we have our intervals labeled as the bars, which is really, really nice.
Yep.
What we can do in this case, once we've corrected that, is we can actually click on the bars. And again, if we right-click on the bars and we format the data series, okay, we can pull up some options. And our gap width is something that we need to tell Excel, yeah, okay, we're going to make that 0 because this is a histogram. And all of a sudden, it's like, hey, now we're getting something that looks a little bit more. Do we need a legend? In this case, absolutely not, because we've only got one set of data. But the one thing that we really are missing are any titles. And again, all these issues of formatting are things that we're going to leave to you to pretty much decide on your own how to do. We can work on them in class, but learning how to format is a little bit beyond the context of this. This is how we've created a graph. And so what we'd want to do in this point and on this version is we want to say, okay, well, what's the layout that we want? And so we'd want to basically give us a title down here for an axis title, and this would be daily high temperature. And we'd want to do on this graph, we'd want to do the vertical. We want to say frequency. And we could even give the chart a nice title, and we could say daily high temperatures
in Waterloo. ERA.
Thank you. In Waterloo for the month of July in the year 2013 or whatever you want. Sometimes this is a little bit cumbersome down here, and sometimes you can actually fix that by spreading this out a little bit more, or even selecting how we display these. But again, that's all formatting.
That you can play with.
So this is, in general, how to create a frequency histogram. And for the most part, that's what you need to know for today. Tomorrow we'll do a little bit more work, and in class we'll get used to playing around with some of these things.